With us, we have Boris Baginski. Hi, Boris.
Switch the audio on, the video on. Yeah.
Yes, we can
Hello.
see you. Hi.
Hi. Great to be here.
Great to have you here.
And great to have a place that is here, which is very virtual all over the world. That's cool.
Yeah.
We have pros and cons.
Yeah.
So it's good.
It's just software in the end.
I mean, if this pandemic was even 20 years ago, it would have gone so differently than now. So we're lucky in that regard, I think.
Yeah.
Boris, so you're director of technology at ATOSS Software, and I was reading that you started development something like 40 years ago, which I believe is longer than most of us have been alive.
Actually, yes, that is right. I started developing software in 1981. Or maybe even 1980. In 1980, I programmed in the shops where there were computers. I had no computer. I went into the shop and programmed a little bit. And in 1981, I got this Sinclair ZX81, yeah, which was new. Then it was just like this machine. It had 1 kilobyte of RAM. Yeah, okay.
Strong machine, yeah. Yeah, you know, actually, one of my first computer was a Romanian clone of the ZX Spectrum. It's an HC90.
Okay.
So sound like 10 years later. But apart from just the printing hello world and the stopping games to poke, you know, I remember the poke instruction because it would allow me to activate cheats and win. I don't remember that much.
Actually, what I did, I developed games at that time and I sold them, but I never played them. Yeah, it was just fun to develop them and to test them and to run them somehow, and then to sell them to earn money with them. But I never really played computer games. Up to this day, I'm no gamer, no idea whatsoever.
I think between us, you are the wiser man because, you know, I spent money on games and you spent your time writing them and getting money. So.
Well, there are people, yeah. Well, okay, but that was when I was young. That was in school, actually. Yeah? I finished my school in '85, and from that moment on, I actually developed business software, mostly for money. And I studied computer science and learned about robotics, and did computer simulations there, which was also quite nice, like 3D simulations. OpenGL graphics in 1994. That was quite cool.
That was when Quake came out, right? That's how I remember the.
Okay, this is how you look at things, right?
Yes.
No, this is the first time we had the backpropagation network really doing interesting things. So it's the early years of neural networking.
That I do not remember. I remember ray tracing, but yeah, we're you're here now to talk about something else, though, about the transformation of a 10 million lines of code monolith, taking it and moving it into the cloud. And I think Dan's eyes are just watering now because he and Sandro Mancuso had a panel yesterday talking about this, almost this very thing, about software modernization, how to take existing application and move them forward.
Yes.
So we're both really eager to find out more about your approach in here.
Yeah, probably you will be a bit disappointed and not disappointed after my presentation because I do not have the solution. I can only sketch some trajectories, but we have many years to come. We will look at it at some point in time, and then we will know how we did it, because I'm sure we will make it. Okay.
When customers especially ask us something, we always say it depends, right? But okay, we'll let you start, and then we regroup at the end, and then we chat more about it.
Yes.
I can hardly wait.
So I share my screen and go into it and just do the presentation, and afterwards I take out the sharing, right? Okay?
Yes.
Yeah, that's fine.
Good. Then let's go. share the complete screen and launch the presentation. Come on, launch. Everything works?
Yep.
It's a black screen by intention. By the way.
Yeah.
Okay, so hello everybody once again. This is an intro that I got from marketing. I asked them, give me a valuable start for a presentation. So, okay, I got diamonds, and I'm still thinking about the association of the diamonds with the software code. And honestly, on the code level, it's hard to find the association with the diamonds because, well, we all know that code is not on the quality of diamonds. But at least I think our software has a kind of quality from the diamonds. It is somehow there for a very long time. So this eternity aspect is something that goes into our software, and I want to talk about that because we, on the other side, we all know we have a constantly changing environment. So eternity and technology changes over time is somehow a contradiction. So let's look into this. I was already introduced as a games developer of the 80s. I'm an abstract artist of the 2020s. I paint colorful pictures as well in my spare time. And so our office is full of these colorful pictures of mine. If you want them, you can contact me, we can discuss. And well, now really down to business. ATOSS is a software company, and I don't know if you know us. We are one of the sponsors of this event. We are happy to do that, but we have an underlying vision that really drives what we are doing, and I like it. I want to focus only one sentence from it. We are paving the way to working lives that are more creative, intelligent, and more humane. I like that a lot. It's a bit abstract, of course, but it is a positive thing to try to contribute to a positive working environment for everybody, for our customers, and of course for ourselves. And you will ask now, what are they really doing, these guys? Yeah, we develop a software that is called Staff Efficiency Suite, ATOSS Staff Efficiency Suite. And this software is handling every aspect of working times. So we are handling time bookings, working time planning for hospitals, for shops, etc. Our idea is to bring the right person at the right time, at the right place. This is something we do, and believe it or not, this is an incredibly complex topic. You have to go with the Workers' Council, you have to work with 10 million legal regulations, all countries different. It's a super complex topic, and we are the number one in the German market somehow. Just one glimpse slide on ATOSS business. It's constantly growing. We are now 530 employees. Somehow R&D is 185. This includes product management. The real guys working on the code is, let's say, 160 roughly, I would say. So quite a big team involved, and we are more or less always working on the same product. Yeah, we have only a few side tracks, so we are focused and concentrated on one major flagship product that earns us the money, and of course it's part of our business is to bring that software to run and to life with our customers. This is a big part of the business as well, but the main engine is the software licensing. And okay, but well, this is a conference about architecture. So this is the architecture of ATOSS when it was founded in 1987. And this is the architecture of ATOSS today. Just to have a feeling. It's a little bit a lie. I have to go to Zeigeroptionen, laser pointer. We actually live in 5 floors from this floor up to that floor. So not the complete tower is the ATOSS tower. This is our headquarters in Munich, and we have also a nice building in Timisoara in Romania at the Boulevard Rebianu, probably close to where some of you are that are now listening. I don't know how international the audience is. Okay. But we don't want to talk about architecture of buildings. We want to talk about architecture of software. And as I said, what the future brings is what the future brings. I want to have a look back in time and show the trajectory over time, because, you know, I think what we did at ATOSS is impressive from an architectural point of view. So it is worth looking at it. It's worth looking at the start of these ATOSS staff efficiency suite in the 80s. It was developed on an IBM AS400, which is a machine the size of, I don't know, a small little, a toilet or something. And this thing was developed, or this thing had a most modern language at that point, and that was Pascal. So the whole stuff was written in Pascal, and you interacted with this thing with serial terminals, which is, you know, from Matrix, the green screen thingy. So you type something, and that is sent to the server, and the server sends some kind of a formula that you have to fill out. And well, that's how the interaction goes on an 80 by 25 text screen device. And also the infrastructure you have to imagine. You have to really imagine the infrastructure at that point in time. You had some machine underground, yeah, in your building somewhere, big machine, super expensive. You had some cable spaghetti because everything was connected with a serial cable one-to-one. And you had some people at office desks using it. A handful of people at that point in time used it. So it was not common that everybody worked with computers. Yeah, only a few people did the job on computers. The rest of the people worked with paper and brought it to the guys who had access to the computer to bring it into the software. Yeah, and this is a screenshot from it. You see what I promised you. This is actually taken with a camera. And this is the 80 by 25 text display, and you see some fields you can fill out. This is even in color. Traditionally would be just greenish, yeah? And then you send them back. Okay, but times changing. Yeah? In the 90s, this kind of computer infrastructure was already outdated, and you see this is already such a kind of revolutionary and massive technology shift. Windows and PCs on the desktop became standard a quarter of a century ago, believe it or not. It was just the anniversary of Windows 95. And by the way, I was at the presentation in Microsoft Munich when it was launched. It was really cool. Yeah, long time ago. But now we have a different infrastructure now and a different kind of environment completely changed. And ATOSS had an established software already after being some 6-7 years in business. We had big customers like Deutsche Bahn, like Lufthansa, which since then and since ever use our software for their personnel to do the planning and the timekeeping. So we had this objective to keep the software alive, on the one hand, and on the other hand, to get it running in a completely new environment. So, okay, what did my ancestors do? Yeah, I started only 15 years ago at ATOSS, so in 2004. So it was before my time, but I have the evidence that it happened, and I have the people who were there are still at ATOSS, at least few of them. So what was done? The logic that was implemented on the server side was cut in part. It was actually cut in part, and the stuff that is responsible to do the interaction with the user was moved into the client. This is drastic software architecture. You have an existing code base and you define a kind of new interface at a layer that was no layer before. Yeah? So you introduce a layer and you say, wow, this goes into the client because we have a CPU on the desktop. Let's bring the computational stuff there because we have computational power. Yeah? Let's use it. That's the client server paradigm. And let's keep on the server only the stuff that is handling the persistency with the database. So the user interaction now takes place here, and everything that is interacting with the user, like validation of fields, like calculations that are only taking place online, are done here. And only if it goes to store, it goes down. Well, and the loading goes up. So we have less traffic between these devices, and we use computational power here. And we have a major architectural refactoring in the code base. But we have preserved the code base. Also, we now have an infrastructure that looks more like we can imagine. Yeah, we already have a LAN, we already have a data center, typically in the 90s. But we are still in one building, or maybe one factory or something like that. Yeah? Internet was not yet really there. This is how it looked then. Somehow, by the way, it's the same dialogue that I showed you before, because that's the essence. We kept the dialogues somehow. Also, we replaced the 80 by 25 now with the Windows display. And you see, this is a transition which was keeping, and to keep everything that was there, we used code generation for the first time. And I'm so proud on these guys who introduced it. There were description files, part of this old Pascal programming on the old 80 by 25 text displays. And this was taken as an input for a Pascal program, parsing it and producing Pascal Delphi code for the UI. And the same was done for the database scheme, which was an index sequential database scheme at the time, to generate the data access layer on the server according to the definitions of the flat files, which were the databases at that time. Yeah? But we see already here that the asset of the stuff goes into a model, into a description, and the code is just a consequence of it. Of course, there's millions of line manual additions to this generated code, but the generated code enforces consistency, and removes redundancy, and allowed transition from one technology to another technology. Great thing, but problem is time doesn't stop. So the century ended and Java became like that, and Pascal actually was somehow discontinued. So the problem is big is big when you stand there as a software company saying, okay, I have a good product, it runs successfully at the market, but all the platform providers, we were on Unix and these AS400 at that time, discontinue the Pascal system, and you do not find Pascal developers anymore. And what about in 10 years' time? So Java needed to be supported. And the marketing department says, buff, we want to sell Java. So, okay, we made a kind of, let's say, marketing-driven approach first. We developed a client in Java, which is just a very, very thin client, just doing the display stuff with a swing that looks like the Windows client, but runs as a Java applet. You can launch it via browser launcher at that point in time, all history for security reasons by now. But okay, we were able to launch the client and download it from a server, which is at least more than before, where you had to install the client locally. But the backend looks horrible. All the presentation logic was moved down again into some kind of blind client that runs one per session. It's incredible Pascal code that does theoretically only the user interaction, and all this communication is done through a thin Java Tomcat application doing the communication with the applet, practically only a communication device to have XML going up and down here. And in the backend, the server is unchanged and untouched. This is a solution, but not a solution. The technology is way too complex. and it's not a solution to overcome anything. So at that point in time, it was a little bit like a dead end for ATOSS development, and we needed a way out because we wanted to achieve, as we did it some years ago, we wanted to achieve keep the software running, but don't stay bound to a platform like Pascal is, that is going away through the changes of time. So this is now the slide where the miracle happens, and that's why I take some miracle colors here. The miracle was that ATOSS was crazy enough to develop a cross-compiler for Pascal. So we developed a cross-compiler, and we developed a framework to run the cross-compiled code. It needed two aspects of the framework. First thing is to emulate Pascal as far as it cannot be created through cross-compilation. So it's a kind of carry objects or holder objects for this thing. And of course, a framework to run a business application of that size to do the whole thing, and having that in Java. So we got Java framework for the execution of the cross-compilation. So we did all this, and actually we succeeded. We succeeded after 4 years. This was my first main project, and I'm to just put it short, I'm awfully and forever proud and happy that we did this crazy transformation, and we not just did it and let it run, we did it good. Yeah? We improved this cross-compiler after we released it for several further years, and we did other transformations and things, and we continued for a while in Pascal and shipped in Java until this cross-compiler was really perfect, so that the Java code we created was almost native Java and not a bad one. So this is a kind of a magic transformation, but it was necessary to achieve our business goals. So this encourages us nowadays, when we think about all the next steps and all 25, 50 years ahead of us, where we have to do probably more magic transformations like this. Yeah. So we also developed a new client, a multi-document interface based on the ideas of Eclipse at that point in time. Our Java client was designed, it's Java, native Java implementation for the client that you have to install locally. All very nice. And this is a client, this is still in wide use for our software. And yeah, it practically displayed the dialogues that we had before on the Windows client, that we had before on the green screen clients. We re-implemented the generator to run with first with XML models in 2007. By now we have the third generation of DSL models with our own Xtext DSLs. We always do a kind of model-to-model transformation. We do much more now with these models. We generate test systems, we generate even test cases, we generate whatever. And the depth of this DSLs is very high. We strongly rely on it. About more than 1/3 of the code lines we compile and ship is generated code from our model files. Record years began, yeah, just well, it happened all the time. That's just where we started taking statistics on it. So the system now I think it's about 11 million lines of code if I count it according to some standard. There are different standards. Others say it's only 8 million lines of code. Who cares? It grew enormously. The team grew enormously in this successful decade until the mid of the last decade. We had passed the 100 people barrier. We had increased the number of automatic tests, etc., etc. So, but we never stopped refactoring. For example, as I told you, we had this file-based database access interface used in the code. Also, that was mapped on SQL databases starting in 2004. We had no possibility to to do any kind of queries, nothing, no standard, no nothing. So we made a complete JPA implementation on our own, and we introduced a kind of DAO interface. And on top of the DAO interface, we emulated the old interface so that we were able to use all the old business code with the old API to do database access. But underneath, we had a super modern, super fast cached implementation, which was based on Hibernate, but we replaced Hibernate by own implementations because we found it not powerful enough for our needs. And with that, we were then able to introduce a complete set of queries, generated queries, dynamic queries, etc., complex queries, so that the business code could be refactored over time at the critical locations to use the power of database queries. Okay, well, so that's just one major example of technology shift. Another visible and major example was then the pressure on web. Pressure on web at the middle of last 5-6 years ago on the business software. It started to be like, you can no longer roll out Java, it's not allowed. So we needed to do another major architectural clue somehow, which we honestly in the architecture team, we found it unfeasible for about 2 weeks of workshops until we had proven the feasibility that we can transform our code. By the way, now I'm sure you can develop everything and you can make every transformation because this was somehow realized as being so impossible, and we made it so smooth in the end. Yeah, we needed to introduce a kind of abstraction interface here that allows us to speak the protocol with the client as it was before, and to move everything which is in the client, which was a kind of rich platform, down here in what we call HTML adapter to run this stuff in the browser. And we needed to support both platforms. Yeah, there was no way to make a kind of, from tomorrow on, everybody has to use the browser. This is not the ATOSS way. So we said, okay, you can continue to use the Java client for the time being, but the browser client you can also use in parallel. And when you like, you can just end the use of the Java client. And now, only now, several years later, we are about to discuss the final discontinuation of the Java client. So our customers have the choice right now, and all the new customers practically never see the Java client, but all the old customers, well, never look at the browser client. It looks like this. This is just a screenshot, nicely designed web UI with a lot of tricks which only stupid ATOSS guys could make, like sidelines that go across table borders, which is really a nasty thing to develop in JavaScript. But well, okay, if product management and the UX team wants it, then they get it to, yeah, well, to in the end display something which was initially an 80 by 25 text display on a web browser. Yeah, so if you just look at these 6 checkboxes here, the 6 checkboxes are still there. Yeah, here are the 6 checkboxes. They are bound to 6 Boolean fields in an SQL database. Here they were bound to 6 characters in a index sequential access file-based database, but no human developer ever touched them in between. So it is a great trajectory of technology success, but it is also a kind, again, of a dead end with regard to what you want to deliver to the customer as nowadays called user experience, because this thing still is somehow a mimic, and it's not only a mimic, it's a kind of continuous development out of a 80 by 25 text display, which was really a burden. So we said we need, instead of this what we call presentation layer 1, this 80 by 25 capability of our code, this old kind of style, which was through the old transformations, it's kind of a big stack, which is hard to handle, and it's not easy to do something with it on a kind of modernization. We said, okay, now, let's take the chance, make our facade API clear for the business logic, and develop a thing we call PL2, a new presentation layer, bottom up on top of the business logic. Let's treat it as it is, and do everything what we have. So it is user experience optimized, use case driven development. It was asynchronous from the very beginning. It has all the powers of a state engine that is descriptive in the models, which then allows you to not have too many conditions and if statements and flags and so on in your code, because that is all done by the framework and based on descriptive programming, etc. So what we now have, honestly, is a nice UI that uses the old business logic, but is a new UI and can be used for many, many use cases. We currently need both UIs to satisfy the needs of the customer, but most users that use the system nowadays, and nowadays every employee in a company has access to the software to apply for vacation, to check his bookings, to whatever, yeah, to do the time recording. You see, this is actually my screen. So you see, I have some 30 hours over hours, and a little bit of vacation left. So we have a nice, powerful UI nowadays. So where do we stand technically? Yeah, we have the browser to show everything. It's nice. We have an internet connection, and we have a server that we start to move in the cloud. So we offer software as a service. And what do we do for the software as a service? We take this thing, which now everybody calls monolith, and put the monolith in a hosting environment and run it in a one-to-one, one customer, one monolith installation constellation. This is the traditional JEE technology dead end, where everybody is now talking of how to overcome. Yeah? And well, now you said you expect from me to give you the solution. And honestly, we spent now about 8 months in the preparation project for this transition. And we, well, let's say when we started some 8 months ago, we thought, okay, we do it somehow, microservices, cut the monolith, slice it, verticalize the code, give the layers away, make the UI somehow an integration service. But all this was, let's say, exploring phase of the solution space. Yeah? And that was necessary. We had consultants coming in that had done this in other companies for other products. And we started to hire people with know-how of things like Kubernetes and Docker, which was, or which still is, some know-how where we are sparse. Yeah, we haven't needed it. So where does it come from? So we are in this building up phase. And only now we are really taking the bootstrap to start the story. And well, yeah, it's an interesting point in time. Technically, we have started to manifest what we call the cloud master plan, and we have some understandings, some basic premises, and some basic ideas, which already are the result of many months' work. Yeah? And maybe you have seen it from the historical trajectory. We will not fall short, and we will not stand back. We will do it. We will execute it, and it will take a while. It will be a big thing to happen. So just some statements we made ourselves a kind of paradigm. Yeah, we are sure that cloud business will replace on-prem to 100% within the next years. That's what we expect for sure to happen. But like I said, it's like with the Java and the web client. We are sure that the web client will replace any other client technology within the next years. There was a paradigm some 5 years ago. And the reality now is, okay, the new customers get the web client. The old customers, bomb. Yeah? You have to take it away from them, otherwise they will not. But okay, anyhow. ATOSS will transition away from being product focused to being globally focused. And here now begins the thing where we all together in the company understood that the cloud transition is not something that only affects the way the product is delivered to the customer. Yeah? Well, that is what we have done. Software as a service, installation and hosting environment somewhere, customer can use it, he gets a URL, duck, yeah, but that's not it. That's not cloud. This is just on-prem installation remote. But the trajectory the things will go away from a product view to some services here and there that somehow integrate at some place in the value adding chain of the companies with regard to their staff management. So we will be a player and driver of this way in our domain. And somehow the most important thing, which also took a while to sink in, yeah, this is a massive undertaking, and it's not an R&D thing. It's not a development thing. It's not the software department alone can solve it. Yeah? It's interesting that this is something that the software development department will practically drive to a certain degree. Yeah, we have to deliver ideas. So these are already somehow conclusions that are also mentioned here because they are important for us in ATOSS to understand. Maybe for all of you, they are obvious. To be successful in the cloud, all customers must use the same current version. Yeah, well, in the end, when there is only one cloud installation we are talking about, then they are doing it from alone. But if the trajectory should lead to that, yeah, we must drive into that direction, that we get the customers at any time on the same version and consistently on that version, instead of what we have now. Every customer has an installation of whatever build from whatever month. That's not that bad. Yeah, they are on quite modern versions, but there are differences. And the other thing is a little bit like the famous Bezos citation here. On the long, all ATOSS products and services provided are accessed via a multi-tenant API, meaning that, of course, we want to have our business underneath as a serverless API somewhere that we somehow integrate, collect with UIs and provide at whatever way. It's also just not such an innovation, but it is so important for us to put that on our agenda in that clarity as a driving principle somehow. Okay, a little bit to our cloud targets and approach. I can unhide because it's somehow in the manifestation of being a plan. And again, yeah, what is happening? We did this preparation phase. Now we are widening our resources that go into it by stuffing and by reassigning people, and this will widen. And then we are willing to invest into that for several years to come to really do it. Yeah? So we will not do it like we send some experimental people somewhere, but we will do it like a big thing. That's why I said, wait for me to report next year in 2 years' time, because then the interesting start switches will already be done. We identified some 5 key ideas for our cloud driver here. First thing is business continuity. As I said, we will not develop some new cloud offering, which is somehow completely different. We will offer a trajectory to our existing customers to be there with us, and even if that is only in 10 years' time. That's somehow an important thing that reduces the risks for us as a company, that we don't want to lose customers. And it's also a driving force. Yeah? But it contradicts things to a degree. We have to balance that. It's a balance between conservative and innovation. Yeah? Then containerization, now we come to the technical drivers. Containerization, of course, instead of having some installations, we need to go fully containerized, sure, which is only true in part by now. a full CI/CD. Yeah, we have developed a nice 4-month release cycle. We were extremely fast with our 4-month releases like 10 years ago. We have this super stable 4-month release cycle. We want to be able to overcome it, to be faster in our processes. Yeah? DevOps, of course, is somehow the combination of it, and beyond it, macro services, saying that instead of this monolithic architecture, this is somehow the target of having some services behind this multi-tenant stateless API to be provided. And well, these are somehow targets. You cannot just say somebody goes there and does DevOps also. So we have identified, let's say, access directions that really bring us there from where we are, because we are at some completely different place. So first thing, simplification, simplify. We want to get rid of things that are no longer needed and make it more lightweight. There are things that are hardly used and things that are somehow outdated, like the Java client on at least, and we must not talk about weeks, we can talk about years. So we want to discontinue, sunset, as they say, features and functionality and code quantity that is just hindering us moving forward, like code that is still there but is switched off since many years, which is cleanup, but that's also technical debt that you don't need to move through time and into the cloud somehow. Same thing is for standardization. Yeah, we allowed several ways of customization, this and this and that. It's somehow a brother of simplification is standardization. Yeah, when you standardize, you can simplify. So it's conditional, but standardize means that you only allow this way, and this way to use the software instead of being vague, possibly, that you allow and you are not sure what the people does, then you have to do release changes, adaptations. We are the lucky ones. We enforced at least that we do not have custom code bases or something like that. But our customization capabilities are so strong that we have to grab them and standardize them, deliver pre-packaged configurations, etc., etc. So this is a big track. And you see now, up to now, simplification and standardization. I only talk about taking hundreds of man years and cleaning up the code. Only now we start with really adopting the technology. And this is I think the strength of the ATOSS approach, saying, well, it's nice to introduce new tools and processes, we need them. But unless we do the other things, we will not come to a successful end. So it's the width of our approach. And okay, we go in, we do a domain-driven refactoring. We start with a domain-driven architecture design bottom up, and then we see how much we can employ on the existing code and how much we can decouple this code. And that is not necessarily leading to microservices. It is leading to reduce complexity and assign responsibility without having too many dependencies crossed over. So this architectural refactoring is again not necessarily fully driven technology-wise. And the final thing is technology-wise. Yes, of course, we have to really adopt new technologies and make a kind of box all around, where we stuff in the monolith or all the new services and make it a kind of engine that runs our stuff, which we somehow provide in a kind of run environment and deliver it and allow in this, what I call box here, ATOSS world sounds better, allow this to fully integrate in our complete company digitalization. So this will be integrated with our internal IT systems, with the ops systems, with the monitoring, billing, licensing, etc., so that we have the ability to no longer ship CDs to the customer, but having a fully automatized machinery that is not only our product, but this global approach of ATOSS to being able to just deliver our value to the customer at the lowest costs and with the lowest effort and fastest possible turnaround and in the best possible quality. To talk about quality at all, we haven't seen the number of test cases that we have anywhere else, probably, but that's a different presentation. So I think I'm at the end of time and at the end of what I wanted to try to capture. There are a lot of things that are really worth digging in, and we will dig into them. But I wanted to put it somehow into a formula, and this is a joke formula, of course. Yeah, we are successful, and we are really very successful with our product, and we are successful because we are able to keep. We are able to keep what we have already achieved as, let's say, functional level of capturing our domain. Yeah? That's an abstract asset, that we can keep, and we keep our customer base and we keep them happy. We guide them through the time. And the change is the required thing to adapt to all this, because it's just no longer possible. The old thing, if you just keep it, there is nothing. There is only dust and rust. So our success is based on a smart balance and let's say no uncompromised compromise between these two forces of keeping things and changing things. And honestly, for me, I made my private formula underneath here. There is a lot of fun going into all this. Really, this project now, again, it drives me, I feel it. It drives me like the Java transition drove me some 15 years ago, which was really, really fun. Somehow from a just what an R&D guy should feel when she or he does the job. And the satisfaction is there when you see it works. And all this sums up to a kind of joy of success. And joy of success is one of the key values of ATOSS. We have this reliability, credibility to revolutionize, joy of success. We have such a kind of canon of values and fairness, 5 values that we postulate to be the driving values of how we are in the company and with the customers. Okay, that's about it. My last slide is always this one somehow, every year new, this year not new, because this took not place. The work is done, of course, by the team. We have this large team, and this photo was taken last year when we had the last annual meeting on the rooftop of our office building in Timișoara. And well, yeah, okay, somehow quite cool. And yeah, I think my time is up anyhow. Thank you very much for listening to me. I hope many people stayed until the end and enjoyed it like I will enjoy the next steps for the next 25 years to come. Thank you.
Thank you, Boris.
I can stop the presentation?
Yes. I just wanted to say, I love how you're saying that simplifications and modularization doesn't necessarily mean microservices. Because I'm reminded of a Netflix engineering article from something like 2 months ago, where they mentioned their big transition from monoliths to microservices, and they reached a point where they had something like 2,200 microservices. So that's a bit of a lot. So now that they need to invent new architecture and need to do domain-driven design on top of the microservices so that everything makes sense and it's composed, and it's just nuts. So thank you for saying this.
You have a complexity. Yeah. honestly, these microservices were so hyped. It took us a real while, and this is why in my slide it's microservices, yeah, because we needed to somehow leave the microservices in because we pushed it into the head of others, and now we have to slow down. Don't think microservices is the solution of everything. There is diplomacy also in this process of getting this launched. Yeah, you see, it's a launching initiative. The real booster is yet to come.
Yeah, I really like the talk as well, and especially going from the beginning to nowadays. And it's because Vlad mentioned the talk I had with Sandro yesterday, and this is what it was almost a case study for that talk. So that how you transition, how the fact that software modernization is not a big bang, but it's just constant change and change where business need to do with software together. So yeah, it was really cool. And yeah, it's a bit disappointing because you didn't give us the end result, right? So.
Yeah, but I promise to be back in 2022 or 2023 with much more of the results. This was let's say, the first step of many presentations. I like to do that, no problem. And we stay in touch anyhow, as we are your sponsor, so that's good.
Even better, but now we also have an estimate, right? So in 2-3 years.
I tell you what, we call it officially Strategy 2025. This is the internal name, yeah, 2025. But the planning we now try to box for 2023 to have a kind of scope that you can oversee. If you think for 2025 all the time, you say, oh, I start tomorrow somehow, yeah. With 2023 is a kind of a bow, but let's see, yeah. And you know, as you said, it never ends. It never ends. It just continues. Yeah, there will be really major steps when we say, okay, now the standard deployment of more or less everything is always fully container-based. We always run in a Kubernetes and straightforward, and everything else is already really legacy load. That would be a kind of milestone that we say, because there are tricky things that we have. We have integrated, well, we have to connect to peripheral devices that require TCP/IP connections and stuff like that. And you don't want to route TCP/IP connections through ingress or something like that. You don't want to do that. Yeah, you can, but you shouldn't. So we need to overcome a lot of things to go forward.
Yeah, so it's also some experimenting to do and going through multiple iterations.
Yeah, yeah.
Okay, well, again, thanks a lot, Boris. Time is up. We need to enter the break. But yeah, looking forward to hearing how this evolves and the story continues.
Yeah, we will do. Okay, thank you very much for letting me attend. And see you soon. See you soon next time again live.
Thank you.
Yeah.
Yes.
But we do it hybrid then,
Until
live
next time.
and remote. I think that optimizes the experience.
Get the best of both worlds.
Yeah. Okay, bye.
All right.
Bye.